Welcome back to our grade 10 maths lessons. I am Miss Awinup, your teacher. In our last lesson, we looked at logarithms and we looked at property 1 of logarithms, okay? We are still looking at logarithms, but today we are going to move to the next two properties, okay? So let's look at property number 2 and 3. Okay, now before we move on, let's just review the index law. Okay, so index law number 2 states that if you divide two indices with the same base, so let's say a to the power of m and divide that by a to the power of n. All right, when the bases are the same, we simply subtract the powers. So a to the power of m minus n. Okay, that's index law number 2. Now, for the log property, all right, log property number 2, it states that the difference of two logs, all right, difference meaning subtracting, all right, difference of two logs, of course, with the same base, all right. What happens here? This is equal to the log of the quotient, okay, UOT, all right, quotient of the numbers. Now, which numbers are we looking at? The numbers that are in the logarithm statement itself, okay? So, index law number 2 states that if you divide indices with the same base, you're going to subtract the powers. If you look at property number 2 of logarithms, it says when two logs are subtracted and they have the same base, then this is equal to the log of the quotient. Okay, now let's assign some symbols and numbers here so it makes more sense. All right, if, let's say, log of x to base a subtract log of y to base a, all right? Two logs subtracted with the same base. This is equal to the log of the quotient, all right, of the two numbers x and y. So x will be divided by y to base a, okay? So this is what that law states, all right? That the difference, or if I subtract two logs with the same base, this is equal to the log of the quotient of these two numbers here. All right. Now let's see if we can illustrate this further by doing an example. This time it should be clearer to us how this law is applied. Okay. So let's evaluate. Okay. All right. Evaluate log 20 to base 4. All right. Subtract log 5 to base 4. All right. Now, as you can see, we are subtracting and the bases are the same. Remember, inverse with division of indices, we subtracted. In logarithms, when you see subtraction, you are going back and dividing. Okay, so this is how they are related. Let's move on and see what we can do here. So same base, subtraction of logarithms. So we are going to find log of 20 divided by 5 to base 4. Okay, 20 divided by 5 is 4. Okay, log 4 to the power of 1 to base 4. So what's our answer? It's not going to be 4. The answer is 1. Okay, so our answer here is 1. All right, so we have applied this log property to evaluate the subtraction of logarithms here. Okay, Now, let's do another example. This time, we'll apply law number 1 and law number 2 together. Okay? So example number 2, 21 to base 5. Okay? Now, we have addition and then subtraction. Now, as soon as you see addition, you know that you're going to be multiplying. As soon as you see subtraction, you know that you are going to be dividing. You are going reverse of index. Okay? So let's have a look. Addition, we will have log 35 times 15 to base 5 minus log 21 to base 5. Okay? Now, 35 times 15 is equal to 525. So log 525 to base 5 minus log 21 to base 5. Okay, now you have to express 525 using the base 5. Okay, after we divide, of course, subtraction now. We go to the next operation, which is subtracting, so we have to divide now. So log 525 divided by 21 all to base 5. Okay. Now 525 divided by 21 will give us 25. So we have log 25 to base 5. Now this number is not expressed with a base of 5, so we have to break this down. You already know 25 is a square number. It is the result of multiplying 5 by itself 2 times. Okay, so log 5 squared to base 5. So our final answer here is 2. Okay, the index or the log here is 2. All right, so we've applied law number 1 and law number 2 to evaluate this logarithm problem. Okay, now let's move on. Property number 3. Okay, again we are going to just touch on the index law first, where we have powers of powers. If I have an index function of a to the power of m, and this is raised to the power of n, okay, we have multiplication here. A to the power of m raised to the power of n will be equal to a to the power of mn. Okay, now our log property, okay, log property number 3. So log property number 3 states that, okay, the log of a number, okay, raised to a power, all right, is equal to, all right, the product of the power and the log of the number and log of number. Again, the number is no other number, it's in the logarithm statement, okay? So we must be clear on this. It's just not any number, it's the number that is in the logarithm statement, okay? So log property number 3, if the logarithm of a number is raised to a power, then this is equal to the product of the power and the log of the number, okay? So let's rewrite this again, so that it looks like this and easier to follow rather than reading all these words. Okay, so the log, all right, let's say x to the power of n to base a, all right, the log of a number raised to a power is equal to the power, which is n, all right, multiplied by the log of the number, okay? So that's x to base a, all right? So the log of x to the power of n to base a will be equal to that power multiplied by the log of this number here. All right? So that's what the law states. We will again illustrate this further by using numbers. That way it is clearer to see. Okay? Let's evaluate. Okay? Now this number here, already you should know n, that's the power from this log raised to that power. Okay, so we have to write this in the required form before we work it out. Okay, and that required form is making this one part of this number here. Okay, so we go. Okay, once you have put this in the required form, then you can go on and evaluate. So 3 to the power of 2 is 9. So we have log of 9 to base 6 plus log of 4 to base 6. Okay, so this is law number 1 again. We are going to apply. So we multiply log of 9 times 4 to base 6. 9 times 4 is 36. Okay, so we have log of 36 to base 6. All right. Again, we express 36 in index form with a base of 6. So this will give us log 6 to the power of 2 to base 6. So our final answer will be 2. Okay. So our final answer here for log 3 or 2 log 3 to base 6 plus log 4 to base 6 is 2. Okay, so we have looked at all 3 properties of logarithms, okay, in relation to the index laws. In our next lesson, we are going to look at properties 4, 5, and 6. I hope you can join me then. I will see you.